In this lesson, we're going to talk about accessibility modifiers as well as private fields and public properties. We'll get to that a little bit later. But let's start off with accessibility modifiers, also known as access modifiers, or I use the term visibility modifiers, and I looked it up on MSDN and they just don't use that terminology. I'm not really sure where I picked that up. Maybe it's what VB calls it. But at any rate, take a look at the shortcut on screen right now. It'll get you to this MSDN article, which is pretty crucial in the explanation of what these keywords are and what they're used for. So you can see that there are 5 different access modifiers, accessibility modifiers: public, private, protected internal, and protected internal. When you get started, you're probably only interested in public and private, and you might accidentally use internal. You'll sometimes see the protected one used in certain scenarios, but as you can see, for example, the word public means that when it's applied to a class or to a method or to a property, it means that it can be accessed by any code, regardless of which assembly that code is in, or which class it's in, which method it's in. It's the most wide open access to that given class or method, okay? And so you'll recall that back in our CS-ASP_041, I basically just copied that project over here and put us back into that initial state, that whenever we attempted to use the character class, we got red squiggly lines, and I was a little confused for a moment, but then I read the error message, and it said that HeroMonster.character is inaccessible due to its protection level. And at first I was thinking, well, hold on a second. We have a using statement and we have a reference to it. Why can't we get at it? Oh yeah, I forgot. And so then I came over here to our class 1 file and added the public keyword. And basically this allowed the default.aspx.cs class, or file rather, to access the character and the dice classes because we gave wide open access to them. However, whenever we didn't have the public keyword, we were using what's called internal. And internal, that's the default for classes. It means that the class can be accessed by any code in the same assembly, but it can't be accessed from any other from other assemblies. So, in other words, character can see dice, and dice can see character because they're both inside of the same assembly, the same project. But anything outside of that assembly or that class library cannot see those two classes because, again, by default, classes are internal. It's basically the same as this right there, okay? Now the other option is to make things private, and private it means that the data type or the member, whether it's a property, a field, or or another class that's kind of has a relationship. We'll talk about that later. Classes can have other classes defined inside of them. We'll talk about that later. But it means that given member, method, property, or even data type class can only be accessed by code inside of the same class. Okay, so that means, for example, if I were to make this, let's make this private, it can only be called from inside of this class. All right, it can't be called from outside of this class. By making this class private as well, it's inaccessible even to our dice class. Okay. In fact, let's do it the other way around just to kind of show you the implication, because let's just go internal here. And we should be able to go build this. Yeah. And you can see here that elements defined in a namespace cannot be explicitly declared as private. Okay, so it doesn't even make sense to declare a class private only unless it's being defined inside of the body of another class, which we'll talk about later. So in our case, we wanted public. Obviously, that's the best one for us. There is one more common access modifier, and that is protected. And that means that the data type, the class, or any of its members, like a method, for example, can be accessed only by code in the same class or in a class that's derived from that class. This has to do with inheritance, and we're not ready to talk about inheritance, so we're not going to talk about protected just yet. Okay. Here again, let's move all these things back to their original. By the way, I don't know if I said this or not, but by default, if we have a method defined like so, that is a private method. So by default, methods are private unless you change their access modifier to public. Okay. So again, to reiterate, classes are internal by default, meaning that they can only be accessed by other classes inside of the same assembly. And members like methods and properties and such are private by default, which means they can only be accessed inside of the same class, all right? Unless you change the accessibility modifier explicitly by adding public or private or whatever keyword that you want to use, any access modifier you want to use. Now, the bigger question that you should be asking yourself is, why would you ever want to restrict access to classes and their members? I mean, why do we even need an internal? Why do we need a private? Why can't we just let everything hang out there? Okay, and this has to do with the topic of encapsulation, and encapsulation is one of the 3 or 4 basic tenets of object-oriented programming. So I don't want to get too deep into that. That's an object-oriented programming course topic. But in a nutshell, encapsulation means that the internal implementation of an object is generally hidden from view outside of the object's definition. So hiding the internals of an object protects its integrity by preventing users from setting the internal data of the component into a valid or invalid or inconsistent state. So one benefit of encapsulation that's often touted is that encapsulation forces classes to implement themselves in such a way that they're only exposing a small number of public interfaces but keeping internal implementation private. And so it can reduce system complexity and therefore increase the robustness of the system by allowing the developer to limit interdependencies between software components. You don't want your components to have high coupling. Coupling is different than cohesion. Remember, we said that cohesion is good, high cohesion is good. That means that everything is working together for a common cause, I guess, in a nutshell. But coupling is when you have 2 objects that know way too much about each other. They're coupling each other, okay? And that's not good because it'll be impossible to break those 2 things apart. So let's talk about encapsulation at a very high level. Think of the implications of this in your everyday life. You have a television set, and nowadays you have a remote control. Back in the old days, they would have like 2 channel knobs, one for VHS or VHF, one for UHF, an on-off button, and a volume switch. And that was it. Everything else inside of the big cabinet was hidden. It was encapsulated behind these well-known interfaces. As even a young child could go up and change a channel and turn up the volume and turn off the television set. But it would take years of explanation to understand the internals that allow that to happen. You don't want to expose all of the wires and tubes and everything inside of an old television set to a novice because they're going to disrupt the integrity of the system as a whole. They're going to screw it up, okay? Think of it in terms of the car as well. You have the implementation, the motor, the suspension, the drivetrain, everything is hidden beneath metal and vinyl and plastic and leather, and it's out of reach of the common user. The user just needs a steering wheel, gas pedal, brake, on-off switch, and that's about it in order to drive a car. So they've encapsulated all of or hidden all the complexity of the implementation underneath the hood, so to speak, and made it very easy to use a public interface so that you can get in and you can drive it. Just imagine if every time you had to drive the car, you had to make changes to the implementation. Ultimately, the end user would wind up screwing it up and the car would be no longer usable. And then maybe another good example is that of a hard drive in terms of coupling. So I happen to have a hard drive here, and I have lots of them laying around for various purposes, but basically they just have two ports. This port is for electricity and this port is for data. Now, that's all I know. But what if we were to open up the casing here and we were able to figure out how to solder wires from our video card directly to the hard drive so that it could cache data without having to go through the bus of the motherboard and so forth. And then maybe we do the same thing with the sound card. We solder a wire from the sound card to the hard drive so that it can retrieve the sounds that it needs to play, and it makes it all faster. And before you know it, we have 2, 5, 10 wires coming out of the hard drive into the various components of our computer system. Well, that would be a high coupling scenario, and the problem is we'd never be able to change out our hard drive. We would have to untangle all that mess, or it would be impossible to even change out another component like the sound card or the video card, because it's hardwired into and coupled to this single hard drive. So coupling is bad in software development and systems in general. But again, this is a topic for the object-oriented programming series. Your main exposure will be to public classes, methods, and properties that are exposed by the framework class library. Okay. Now there's one other thing that I want to point out here. We don't just have these methods that we've defined, which by default are private, but we make them public by adding the public keyword. We also took the random object and made a new instance of it outside of the scope of the role method, and we talked about the reasons for that, and I don't want to go back into that again, but essentially what we did was we made a private field called lowercase random of type uppercase random. So when you declare a member in this way or in this way, it's called a private field, and private fields can serve two purposes. First of all, a private field can be used whenever you want to keep an object or a variable around for the private use of your class's implementation, as is the case here. We don't want to expose the random class to any other class. It's only to be used internally. Nobody else should even know how I'm implementing a random dice roll. That's not for them to be concerned with. I've given them a public sides property and then a public role, and how I handle it from there is nobody else's business. All right, so that's one reason why you want to use a private field, to keep a reference around of objects that you're going to use or variables that you're going to use as the internal implementation inside of your class. But the second reason that you would want to use a private field is because you want it as a backing value for a public property. So what does this mean? Well, all along I said, hey, whenever we're doing prop tab, we're creating an auto-implemented property, which is a very simple version of a property. But I said later on we're going to talk about more complex versions of properties. So for example here, what if I wanted to create another property, and I'll just go prop full tab, and now we can see the more full-blown implementation of a property. In this particular case, notice that there's a get and a set, and what happens in the set is that whatever is passed into or set, like for example for my property, let's go up here to here we have a dice object, so let's go dice dot my property equals some, or I guess it's an integer, so I'm going to have to go 1, 2, 3, okay, like so, right. All right, so at this point, that's when this code kicks in. We're attempting to set the my property to 1, 2, 3. But here we get the opportunity to stop that from occurring if it doesn't meet certain criteria. So for example, we could do something like this. If the value is greater than 1000, then we'll set my var equal to value. But otherwise, we're going to raise an exception, and we'll talk about exceptions later. But basically, we're going to say, nope, can't do it. Don't even try it. You did it wrong. and it can become a gatekeeper for private fields. And again, this is another way that you can enforce encapsulation. You're keeping private variables, private fields, like this private int myvar, hidden from use, and you put them behind a gatekeeper, this set method, which makes sure that my var can only be set to certain values that are appropriate for my application. In this case, my fictitious application would expect a value greater than 1,000. I'm trying to give it a value less than 1,000, and the application should protest and say, you can't do that. It doesn't make sense for my property to be less than 1,000. So again, think gatekeeper, why you'd want to use the full-blown property and private field arrangement like this. Now there's one other code snippet we can use, is prop G tab. And so what this does, it allows us to do what's called a private set, but you can still do the get. So this is like an auto-implemented property. It just makes the set private, and which would ultimately mean that the only way that my property can be set is from inside of this class. That means you can't access my property from outside of this class. As you can see here, the property or indexer, my property cannot be used in this context because the accessor is inaccessible, all right? And so this might allow us to allow other people to read the value, but we have code inside of our class that determines what the value should be and sets it to some sane value based on other inputs, all right? Okay, so at this point we're drifting into object-oriented programming, and I want to save that for that series. But just remember that auto-implemented properties are great, but if you need to ensure the integrity of the object, then you want to use a full-blown property, and it will have backing private fields, and you'll use that set, here, prop full tab, you'll use the set to do some checks, some sanity checks, some gated checks on whatever the value that is being set to, whatever we had it set to here. So that's public property protecting a private field. And at a higher level, we talked about encapsulation, and that's why we would want to limit access outside of the definition of a given class or a member like a method to ensure the integrity of that object, okay? So I realize this is a bit heavy. Just remember, public means you can access it, private means you can't, okay? And you should be good to go, and we'll talk about this at more length in the object-oriented programming series. All right, so that's all I got to say about this. We'll move on to the next topic. Thank you.